Hello everyone. Today we're going to talk about forecasting. Forecasting is our topic for the week. And I'm going to go through some models of forecasting and give you some ideas of how forecasting can be used in various different business scenarios. So let's start off by first asking the question, what is forecasting? Forecasting is basically predicting the future. It is trying to answer the question about what we think is going to happen under a given set of circumstances. So it's similar to like the weather forecast. We could be in a position as a weatherman to have to forecast the future. What are we forecasting for the next 10 days? And we're going to base that on some amount of information. And this gets back to the whole concept of forecasting. Forecasting, while it is guessing at the future, it is doing so in a way that is as data informed as it possibly can be. In other words, we are going to look at past data, we're going to look at present conditions, we're going to look at trends, we're going to look at things like that in order to be able to make the most educated guess as to what the conditions are going to be in the future. And that's really what a weatherman does. A weatherman looks at what has been happening most recently, what happens during this time each year, what are the factors that might be influencing the weather, and makes a prediction or a projection based on data that comes through computer models to determine what the weather is likely to be. And that's really what forecasting is. Good forecasting is making predictions about the future based on good sources of data. Many types of forecasting models. There are many types of forecasting models that differ in complexity and the amount of data and the way that they generate forecasts. One thing to remember about forecasting is that forecasts are rarely perfect. I think everybody can sort of understand why that is, because we're basically estimating the future. Forecasts are more accurate for grouped data, and that's basically data that comes in groups. We may be looking at a collection of forecasts having to do with how many people are going to be in classes in the next coming academic year. That's going to be more accurate because of the more generalized nature of it than it would be if it was a single class. And the forecasts are more accurate for shorter than longer time periods. We could be forecasting for a 6-month period, and as opposed to a 18-month period. The reason why it's going to be more accurate for a 6-month period is 6-month period is going to be more recent relative to the time that we're basing it on. It's also going to be less period to cover where there are things that can change or go wrong or shift. Let's look at some types of forecasting methods. Let's first of all start about how we begin to forecast, and that is we decide what needs to be forecast. So is it going to be sales forecasts? Is it going to be revenue forecasts? Is it going to be enrollment forecasts? Is it going to be traffic forecasts? Those kinds of things. And what are our units of analysis and the time level or the time period for which we actually want to conduct that forecast? Then we evaluate and analyze the appropriate level of data or the appropriate types of data. So if it's budget forecasting, we might look at, well, how much money did we spend last year? What was our budget last year? Or what was our budget in the last 6 months? Or what was our budget for the last 3 years? And then try to gather the best data that we possibly can. Sometimes that data is not available, and so it becomes a challenge to try to gather the best data possible. Then we go ahead and select and test the forecasting model. What model are we going to use? That's going to largely be driven by how easy is it to use, what data is available to us, and what can we make of that data. We'll go ahead and generate the forecast, and we'll go ahead and make our predictions. And then as the period that we forecast begins, we keep a pretty close watch over how accurate was our forecast. And we determine the accuracy of the forecast, and we then adjust for it as we need to. Let's look at some more forecasting methods. There are two categories. There are qualitative methods along the top there and quantitative methods. And we've got on the left-hand side, we've got characteristics, strengths and weaknesses. So a qualitative method is basically us understanding kind of the qualities of an organization. So how do things work in an organization, or how do things work? How do people feel about the way things work? That kind of stuff. Those qualities. It's based on human judgment, human opinions. It's subjective and it's non-mathematical. It has some strengths. The strengths are it can incorporate the latest changes in the environment and inside information. In other words, if we're simply looking at mathematical models such as budgeting, how much money did we spend last year? And that's what we base our forecast on. We may be leaving some human factors or some human elements out that that can seriously impact our forecast. The weakness of the qualitative methods is that we may bias our forecast on things that are just really feelings or hunches or beliefs without really having much to back them up. Quantitative methods are really based on mathematical models, and that's where you see most of your forecasts happening in business environments especially. And what you're looking at is you're looking at, a mathematical or a spatial representation of some event or some phenomena, and you're saying, okay, based on what I've seen in the past, this is what I'm likely to see in the future, with some slight adjustments. The strengths of it is that it's consistent and objective. We're able to consider much of the information and data at one time. The downside is that often quantifiable data are not available. It's tough to get that information. So if you think, for example, about traffic patterns, and we wanted to project traffic patterns around a city, we may not have that available or that data available to us at any one point in time. And then sometimes it leaves out the human element, as I talked about before. A little bit more about the qualitative methods. The forecasts are generally subjective, and they're subjective by the forecaster, and they are largely educated guesses. The quantitative methods, the forecasts are generated through mathematical modeling, and that's just basically repeating what we've just said. But it's important to note that most of what we're doing in forecasting falls back to that quantitative method. Let's talk a little bit about the qualitative methods that we can use. Qualitative methods are things like executive opinion, over there on the left, market research, and the Delphi method. An executive opinion is basically a group of managers at a company or organization come together, and they meet and they make a forecast. It's good for strategic or new product forecasting when we really don't know what is going to happen. If we have a new product line or a new product, and we're going to go ahead and try to forecast what the sales results of that new product are going to be, we really don't know what that's going to be. And there's going to be many things, many feelings, bit of market research, that kind of stuff that's really going to drive that forecast. But we don't have a mathematical model on which to base that. Its weaknesses are that one person's dominant opinion can actually throw everything off, and there's really no grounding of that executive opinion. Market research is where we actually go out and we do the work. We look at what's going on in the market, what are the trends, how will a product resonate with customers, that kind of thing, and we use that to sort of make our forecast. Its strengths are it's a good determinant of customer preferences, because one of the things we do in market research is we ask customers, find out from customers what they want. The downside is that it's going to be difficult to develop any sort of good questionnaire or any sort of good process of getting information from customers, especially if the product is new and we just don't know how the product is going to resonate. Then there's a last one here called a Delphi method. This seeks to develop consensus amongst a group of experts. These could be experts probably within and outside of your company. And it's good for forecasting long-term product demand, but it's also time-consuming, and it can be very difficult to implement. So those are the qualitative ones, the ones where we're actually kind of going on sort of human feeling and subjectivity, where we think we've got some experts and some expertise, and we're going to use that information to sort of inform a non-mathematical model to forecast behavior of an organization. The quantitative methods fall into two categories. The first one is a time series module. The time series, this is one that's getting back to past. We are looking back into the past, and we are projecting the future by looking at the past, and I'll talk about different ways that we do that. The causal models or associative models are ones where we're looking at certain variables and determining how can we predict the behavior of one variable based on the behavior of another variable. And you'll see some stuff that looks familiar there. Time series. So in a time series model, the forecaster looks for data patterns as data, the data that we're looking at, equals historic pattern. Remember, we're going back into the past, plus or minus some random variation. Okay, that random variation is about as random as we can get here. We're not really defining that very well at all. So the historic pattern could be sales averages, it could be sales trends, it could be seasonal behavior, and the random variation is the thing that we really can't predict. It could be big, it could be small. We hope that it's small, because if it's small, it means that our forecast is more accurate. But it's essentially what we're determining is based, again, on that historic pattern and how much that shifts or changes. So a historic pattern to be forecasted can be focused on a couple of different things. It can be focused first on what we call level, and that's what Foreman uses. He uses that term as well. And level is a long-term average. That is, the data fluctuates around an average. So we may have an average sales that has been our average sales for the last 3 years. And every month we see something that is slightly higher or slightly lower than that average sales number, but the average sales number itself doesn't shift that much. So it's a very sustainable model in the sense that the average is the same and we just shift a little bit around that average. Trend data is different, and this is what we see a lot more, and this is also something that is a lot harder for us to sort of track. And trend data is where the data exhibit an increasing or decreasing pattern. So we may have a product line that we implemented or introduced a year ago, and it's sort of doing kind of the level where it's sort of hovering around that mean. Then all of a sudden, about 8 months ago or 6 months ago, whatever, it just takes off, and we're starting to see sort of the hockey stick effect where the sales have dramatically increased, and the popularity of the product with the customer has gone way up. This is really a lot harder for us to predict from a forecasting standpoint, because we just don't know how much that increase is going to be sustained over time. At some point, that increase will flatten out and will start to look a little bit more like level. But when the trend is growing, it's shifting. The other thing about it is when the trend is starting to decline, then it becomes also very difficult to predict, because that could be a product that's ending, or it's getting close to the end of its life cycle. Seasonality is a forecasting methods that takes into account the different popularity of a product or service based on the time of year. So a great example would be Christmas lights. Christmas lights are going to be really hot in November and December. Okay, but pretty much not so much anytime else. Also ski gear. If you're selling ski gear, you can forecast that you're going to be able to sell a whole lot of ski gear for snow skiing in the months of September through, I'm guessing, February, maybe March. But then in the summertime, those products don't sell so well. So this model of forecasting, if you're going to forecast for an entire year, you're going to forecast your hot months and you're going to forecast your cold months, and you're going to come up with a level of sales, a level of revenue that is going to basically sort of take it both into account. And cycle is probably something that's a little more long-term, and it could be a good one would be the housing bubble. Right now, the housing bubble, probably in many metropolitan areas in Washington State, the housing market is super hot. And so if we were to forecast what we're likely to see in housing in the next 12 months, we would probably really show a very aggressive, very active housing market, certainly in Western Washington, but certainly Eastern Washington is experiencing this as well. At some point in time, that's going to level out, or it's going to start to decline. And so then we'll see a downward cycle, and that downward cycle could last for months or years. But it's just something we just have to take into account and take into effect when we're using the cycle forecasting method. So those four processes, I should say, level, trend, seasonality, and cycle, are ways that we can go back and take into account what has happened in the past and look in the past. Clearly, the easiest one is level. Seasonality, if it's predictable, can be pretty easy too, but we just don't know the differing degrees. Trend and cycle are harder to track, but those become our data. The historic pattern, those become the data. Then we add in the random variation, and the random variation is one thing that's harder to predict. That could be caused by growth, it could be caused by decline, it could be caused by many different things. Here's a graphic that shows the four different levels. The first one is the level or the horizontal pattern, and you'll see that the line is really kind of similar. It kind of fluctuates above and below what is essentially probably a mean line, and that is an average across time. Then you see the trend pattern in the upper right-hand corner, and that is where the product is starting to take off, and it's starting to actually sell more. And the issue is that we really have a tough time predicting that or forecasting that, because we don't know how long that increase is going to keep going. At what point will it stable out and level out, I should say, and stabilize and turn to look like what's in A. So it's more difficult to predict. The seasonality, if the seasonality is consistent and we can go back several years and we see this seasonality, then we can sort of say, yes, we've got a known pattern here, and we just know we're not going to sell a lot of snow ski equipment in the month of June. It's just, unless it's really on sale or something, but it's not a hot time for that product. And so we just build that into our pattern. And ideally, we get enough information and experience that we can have a really well-informed model. Then the cycle, again, is if you're looking at time in quarters, that could be in the first year. Product line we're looking at is pretty hot in quarters 1 and quarters 2, and then it takes a dip and it goes down for what looks like to be about 2 years, and then it starts to come back again. This could be a housing market. This could be the market for durable goods. It could be a number of different things. And it's really hard to predict. Some economists will tell you that it's more predictable based on certain factors. But if we're just running a small to medium-sized business and we're trying to figure out what our product sales are going to be, and it tends to follow sort of this or be impacted by this sort of cyclical pattern, it's going to be hard for us to predict what that is. Let's talk about some time series models. I'm not going to go into a lot of detail here, just simply because you can either read it in the form and text, but we're not going to go into any sort of real exercises that go into detail, but I'll go over these to tell you what they are. A naive model is where basically the forecast is equal to the actual value observed during the last period. So if we were to look at last quarter ended on March 31st, 2017, and we were to say we sold, say we're selling cars, and we sold 2,000 cars. So our projection for the next quarter is going to be 2,000 cars. We're going to sell 2,000 cars again because that's what we did last quarter. That's as naive as it gets. Simple mean is where we basically average. We average all the available data. Now we're going to go back further than one quarter. We might go back 10 quarters, or we might go back, who knows how long. But we're just going to come up with a straight mean, and it's an average. And this is what we do for leveling. When we actually run a level model, we calculate the mean, and then our variation is around that actual mean level. A moving average is actually a kind of cool tool, is where we account for, if you're just looking at straight average, what you're not able to account for, or what gets buried in the average, is any sort of growth or decline. And that gets sort of factored in. It does impact the model, but its impact is greatly reduced. When we go to moving average, what it allows us to do is allows us to take into account the more recent data and give it much more weight. And that's actually really useful. So what we can do is we can say the last 4 quarters, you're going to base your sales projections on the last 4 quarters. And then as you roll forward in time, the last 4 quarters always changes. So you get to a point where you're constantly updating your average. It's based on the most recent 4 quarters, and you're able to project something that actually follows on to the most recent patterns. The one that Foreman talks about in his very first example is exponential smoothing. And exponential smoothing, basically what it allows us to do, it's a little more involved, but it allows us to look at the performance, it allows us to look at our projection, we look at the difference between our performance and our projection, and we calculate that and use some sort of alpha value to determine what our next projections should be. So, and this actually is a rolling or a moving average as well. It just goes month to month or period to period. So if we're focusing the next quarter, we're going to look back at the past quarter. We're going to look back at what did we project for that past quarter, what was the actual for that past quarter, and we're going to use that to determine what our likely variation is going to be for the coming quarters. And if you really want a lot of detail about this one, go ahead and take a look at that in the form and text. The causal models are a little different in the sense that what we're looking at here is we're looking at the relationship between 2 variables. So often leading indicators can help us predict changes in future demands. For example, housing starts. Housing starts is definitely a causal variable to a number of other variables. So if we're able to measure for a city the number of housing starts, this is going to help us have a better understanding of the number of related products or related services that are going to be needed in order to build those houses. Causal models establish a cause and effect relationship sometimes between independent and dependent variables. A common tool of causal modeling is linear regression, and that's one that we've actually looked at. We'll look at it again in more detail this week, because in the other presentation that I'm going to submit, you're going to do linear regression in R. Let's talk a little bit about correlation and causation. This is actually related to your discussion board question this week. Correlation is where 2 variables are similar in the way that they move, or the way that they increase or they decrease. So, for example, if I have variable A, and I know that when variable A goes up, variable B tends to go up as well. They may go up in a linear way. In other words, A goes up and B goes up by some known measured way, or they may go down together. B goes down, or A goes down and B goes down in some measured way. But they do not cause each other, and that's an important point. They do not cause, the increase in A does not cause the increase in B, and they may be loosely related. In other words, if, for example, higher employment in a city may be related to higher levels of durable good purchase, but it may not, and we don't really know that. And what correlation actually allows us to do, it allows us to sort of look at the strength of the relationship. So if we know that, for example, higher unemployment rates in a city correlate very positively with higher college attendance, then we can measure that. We can measure the strength of that relationship. But we don't know that higher unemployment rates cause higher college attendance. They're just two variables that are related. Under causation, you actually have two variables where one actually does cause the other. So the increase in one or the decrease in one causes an increase or decrease in the other. And one that you could look at would be housing starts, the example that we just talked about. Housing starts, if you have housing starts, you are going to need markets to grow that will support the construction of those housing units. So that is a direct cause and effect relationship. Another one would be if you've got a company and you're investing in research with the goal of developing new products. So you invest in your R&D, likely that you're going to develop new products, and that investment is a direct cause of the effect, which is additional products. So again, correlation is two variables are related. Causation is one variable. The change in one variable causes change in another. Let's go back to linear regression. We've talked about linear regression a little bit. We did that in the previous presentation. But just as a reminder on linear regression, we've got two variables. If we have the value of our x variable, which is our independent variable that feeds into our linear model, and we have the slope, and we have the intercept, we can use those three values, x, slope, and intercept, to predict the likely outcome for our output variable or our dependent variable. So again, if we have, for example, the amount of money that we put into research and development, and we're trying to figure out, well, what is the likely number of proposals that we're going to get out of our research and development team based on the amount of money that we put in. X is our independent variable. It is the amount of money that we put into the research process. We will use R or some other statistical model to calculate the slope and intercept, and Y will be the outcome. It will be the number of likely proposals that we're likely to get out of research and development team. We're going to actually go through examples of this in the other presentation. So let's use an example. Walk through an example that might be relevant to you since you are all in university. So an academic program, let's just say it's ITAM. So ITAM has to do forecasts every year, and it has to forecast how many students are going to be in that program every year, and how much revenue is going to be associated with the number of students that are in that program every year. So at some point in time, the administrators of the ITAM program have to sit down and they have to make projections or forecasts. And those projections or forecasts determine how many enrollments are they likely to get in the undergraduate ITAM program in the 2017-18 school year. And that drives revenue, because if we know the number of enrollments, we can project out the number or the amount of revenue. What they also have to do is they have to sit down and figure out, well, how many expenses are we going to have? So how much do we have to spend on faculty, on resources, on books, on administrators, those kinds of things. So those all have to be focused, are forecasted out, and those all have to be determined. So the point of forecasting that is that, I mean, it's a fairly large state university. Why do we need to forecast this? So the point of doing that is so that our expenses don't exceed our revenues. We are trying to run a profitable, viable business, profitable, viable program. So we have to track out how much revenue we're likely to make. That helps us determine the amount that we're likely to spend, or the amount under which we need to keep our expenses. So we know how much money we're going to make through forecasting, and we know how much that leads us to know how much money we're going to be able to spend. So how do we know that? How do we know, first of all, revenues, enrollments? So the first thing we can do is we look at the past enrollments. So if we're going to project enrollments for 2017, 2018 in the ITAM program, we can look at what happened in 2016, 2017. You know, for every class in every quarter, assuming the schedule is comparable, how many students did we get last year, and how much can that inform what we're going to do this year? Okay. We also have to look at things like, what are the variations? What are the trends? Is there been a big increase in the number of applications for the ITAM program? Or has there been a decline in the number of applications? Did we have a bunch of students graduate and now we're having to look to replace those students in the program? Are there new classes or new emphasis areas where the students can enroll, and is that going to draw new students? So we look at all these things. These are all, so we have the past data. We talked about the past data from last year. We may even go back a year or two. We look at trends. What is the percentage of growth from year to year that has been happening over the last 3 or 4 years? And we use all of that information to make a logical guess or projection or forecast about what we think the enrollments are likely to be for the coming year. We also have to look at how those things are going to impact expenses. We know how much it cost us to put the program, the ITAM program, on from 2016 to 2017. We know that for all the previous years as well. So we can look again at trending. How much has it gone up or how much has it gone down? We can look at the static sort of way. We can do the leveling. What is the average expense per month to run this program? And then we can also take into account, well, if we have growth, we're going to need more faculty. And if we have growth, we're going to need more resources. So let's assume that the growth is happening and it's happening at a faster rate than we are going to be growing our expenses. So the idea is that we will have to step up our expenses commensurate with what we're doing in our enrollments, and that's going to be another forecast that we have to make. We talked already about forecasting strategies. Some organizations do this with very little effort. They actually are very well-established organizations. They've been selling the same products for decades. They have very low risk in making fairly loose forecasts, simply because they're based at they can base their performance on so much sustainable sales history. They don't really have to do a whole lot. So there are organizations out there that really don't do a whole lot of forecasting. A lot of the organizations that are out there, whether they're small organizations, medium organizations, or even big organizations, are going to look at what they did in the past, and they're going to basically forecast just based on one of the 4 strategies I showed you, but it's going to be based on past data. There may be some fluctuation built into the model, but it's really going to be like, we sold 1,000 units last year. We're probably going to sell 1,000 units this year. Maybe we'll sell 1,050 because we've seen an uptick in the market. It's going to be that kind of stuff. There's not going to be not a whole lot of changes. A lot of organizations, however, and this is kind of a good spot to be in, are faced with having to look at 2 sets of data. First of all, they're going to look at what they did in the past. Last year we sold 1,000 units. Then they're going to look at a couple of other things, such as, well, how much has our growth been happening, or how much growth have we been having? And what about a change in our process or our procedures? Are we able to produce more? Will that actually get out to the market? What about new strategies for sales? What's going on in the market? Those kinds of things. So all those things have to be taken into account when trying to make that projection. The idea is you want to project as accurately as possible. If you project too low, then you'll keep your expenses too low, and that can really hinder your growth. If you project too high, you may not make your numbers, and if you have set your expenses related to what you projected for your sales, you could be in financial trouble. You could have expenses that are too high to be supported by the actuals on your sales. So you want to make your forecasts as accurate as possible so that you can keep your business healthy. So we've talked about these as well. These are kind of different forecasting strategies. We have weighted means of past performance, different ways of being able to look at past performance and say, this is how I'm going to use it. We've talked about trended growth, and then we've talked about analysis of the marketplace. So I'm not going to go into much more detail on those. And here's another example, and I've kind of talked around this example, but I'll go through it real quick. The annual budgeting process. Almost every organization has to set a budget. They have to establish what their budget's going to be for the coming year. So they're going to come up with 2 things. One, how much money are we going to make in our revenue streams, and how much money are we going to spend in order to be able to support that business model? So the first step would be, let's look at what our revenues are going to be next year. And this is a forecast of revenues for the coming year. What we'll do is, first of all, look at past years. What did we do last year? What did we do the year before? What did we do the year before that? They may use something, remember we talked about the recency of data when looking at past data being really important. They may look at something called a 6+6, where they make it to the middle of the year and they say, okay, we projected out that we were going to spend X dollars. What did we do so far in the first 6 months of the year? How did that match our projections? And so they'll take that into account, and then they'll add to it, what are we projecting out or estimating out for the following year, and come up with an annual projection for the next budget year. They have to do things like analysis of marketplace. They have to, are there any seasonal impacts? Are there any trend impacts? Coming up with what their likely revenues are going to be. Step 2 is going to be, all right, now that we have our revenues, what are our expenses going to be? So how many staff are we going to need, and what are we going to need to spend money on, and what are all our expenses, our postage and our shipping and all that stuff that we're going to need to be able to do? How much is that all going to cost? And this is our forecast for expenses. Then they need to look at, well, how does that relate back to the revenues? for a business to be successful, it has to be able to survive financially. And if its revenues are smaller than its expenses, it's not going to make it. So this is really kind of the highlight of the importance of forecasting. We have to forecast our revenues, and those revenues have to meet or exceed our expenses for the business to not fall behind or potentially go under. So it's really important to be able to look at both of those and compare those and make the right adjustments to them as needed. Once we're done, we've created our revenue forecast and we've created our expense forecast. Now we are going to monitor our results. And this is oftentimes in a business setting. It's done by the business office or the accounting office, but it could also be done by production, by operations, by those kinds of things. We want to actually keep track of where our forecasts are and where they diverge from reality. And we'll go through and potentially adjust our models. More likely, it's going to be adjusting behavior. Once we set a forecast for revenue and set a forecast for expenses, it is unlikely that we would change those forecasts. What we're more likely to have to do is go back and change the reality. So by changing the reality, that means bringing in more sales. If we're lagging behind on sales, or on the expense side, we have to cut expenses. We have to get those expenses down, which means potentially hiring fewer people, spending less money on postage and shipping and those kinds of things. Whatever it is that's eating up our expenses, we have to get those back in line. So a constant process of managing a business and looking at the data that the business is using is tracking where we are at relative to what we forecast. The whole goal is to be able to come in and ensure that our results will be what we want them to be, and we have to take action if they're not going to. Monitoring your forecasts may be the best tool you have to actually make sure your forecasts are accurate and make sure your forecasts are realistic. So for this week, what I'm going to have you do is I'm going to have you read the Foreman chapter. Don't worry about reading a whole lot of it. It's a very long chapter, but read the Foreman chapter just to get a feel for forecasting and how it's used. And that first example is actually the exponential example. It's pretty good. Look over Big Data, the Big Data book. Don't forget about that one. And this week, the chapter is on implications. And this implications, I think it's really important for us to understand what the implications of what we can do with big data are. And then I will post also, in addition to this presentation, another presentation that talks about the weekly exercises. In the weekly exercises, I'm going to teach you how to load data in R and run single linear regression on a data set. If you have any questions, go ahead and hit me on email.